Okay, and the last one before we go and have our lunch is Dr. Ian MacDonald. And, Ian MacDonald is an oceanographer at Texas A&M University, Corpus Christi. He received his PhD in 1990 from A&M College Station, and he's been here in Corpus Christi since 2002. And he also works at the Art Institute. And I had the pleasure of last September going out on a Gulf of Mexico cruise and got to see pretty much what you were talking about, Karen. It's not only oil, but it was trash and dirt and everything else. And it's on there.
That's it.
And so Scott pulls that off.
That's the one.
That one from space. Now, the deal is these images here. One of the first things we found when we started putting the website together, and I got an email from a guy in Canada. He says, "Hey, I see you're using my picture. I really appreciate it, but I need some credit." Actually, my bosses want me to give some credit, and so we've been kind of emailing back and forth, and then Ian has graciously and bravely agreed to present their data because he's doing very similar work in the Gulf of Mexico with satellite imagery. Thank you, Ian. I appreciate that.
Roped was the word. So I'm presenting a talk, and I'll try to be brief because I know we all want to go to lunch. But I'm presenting results that Jim Gower and his associates at the International Institute of Ocean Studies in Sydney, Canada, have presented. And Jim Gower, according to his little bio in the paper, got his PhD in '67 as a radio astronomer and moved to Canada in 1971. Has been at the IOS ever since. So what Gower and his associates have done is they've used the medium resolution infrared spectrometer, which is a spacecraft orbiting the Earth, and they've used the data from that to look at offshore occurrences of sargassum. And what they're specifically doing is they're looking at what's called the red shift. The green plants absorb energy, and they absorb energy in the green region. And as a consequence of that, when you get beyond the sort of green wavelengths, there's a spike in the longer wavelength radiation, and that's called the red edge. And that red edge is used to detect the presence of green plants and photosynthesizing processes. The red edge in oceanic settings is somewhat a shorter wavelength than it is in land plants because of the absorption of IR radiation by the water. So he's used this data, and the data have a spectral resolution of about, or a geographic resolution about down to about 300 meters. But most of the data he's looked at are about on the order of a kilometer. He's got an interesting historical review of people trying to map the occurrence of sargassum, going back into as far as 1820. We've already been farther back than that, looking at Columbus, but interestingly, there was a belief that there was a vast undiscovered reef in the Gulf of Mexico, and the occurrence of sargassum was considered evidence for this reef structure, and so it was mapped by a number of different sources, including the Germans. And it was finally not until the latter part of the 19th century was it recognized that this is can be a purely pelagic species. Okay, so that's a little of the history. Here is the data that he's showing here, and it's a little hard to see this, but these are long, what he calls slicks or stringers of sargassum. And what these are places where there's a convergence of water masses, and so on either side of these long lines, you have water that's downwelling, and the lines of sargassum accumulate along these convergent structures. And in fact, any of you who've taken oceanography may be familiar with long mirror circulation. and these are long sort of linear streaks that develop. You've probably seen them when the wind is blowing for a long time. And Longmire actually used the Sargassum mats as one of the confirmation features for his look there. And so this is the spectral signature of these mats here, and you see this protracted red edge of the Sargassum signature. So this is Sargassum in the Gulf Stream, and with a peak radiance of 709 nanometers, so just at the edge of the visible wavelength. Okay, and these are, he's gone back and looked at, used these satellite data to look at the occurrence of Sargassum mats, both in the Gulf of Mexico and the Atlantic, going all the way back to 2002. And in fact, in his papers, he actually compares the satellite data and the seasonal timing of these Sargassum blooms or Sargassum events with historical records collected from ship surveys going as far back as the early 1920s. So he's got an interesting time series using satellite data to compare with shipborne observations. And the data appear to be pretty consistent throughout his range. And what's intriguing here is that the Gulf of Mexico accumulations of Sargassum precede the accumulations in the North Atlantic gyre and in the North Atlantic generally. So now he's interpreting these data, and I think this is kind of an intriguing question for us here, as that the source of the Sargassum is the Gulf of Mexico. I'm not sure that his data entirely prove this, but at least it suggests that the blooms start earlier in the year at the very least, and there may in fact be some net transport out of the Gulf of Mexico and into the Western Atlantic. And so here are the onset here. These are floating Sargassum mats from April 20th, 2008, and it starts to appear in the Gulf of Mexico early in April. You start to see these, this is the initial appearance of the mats, and then by later on in the year, you're getting, or a couple of months later, you're getting a much increased volume here, and he's indicated these. Now this is sort of the 1 kilometer kind of data that he's showing, and so we're getting, an idea of very large amounts here. Just a couple more slides, I guess. Okay, and so here is the extent of Sargassum and a sort of a annual time series, which he's showing for these data. And so he sees an origin starting in about March, and then spreading throughout the northern and western Gulf of Mexico, and then not really appearing in numbers in the until September and July, November and February in the Atlantic. So he interprets this as that the Sargassum are originating here in the northern and western Gulf of Mexico, that they're being carried out of the Gulf of Mexico by the loop current and spreading up the west coast of the Atlantic, or west coast of the United States. And he suggests, based on his time series data, that there may be as much as 1 million tons of Sargassum being exported every year out of this system. I was kind of intrigued if that's the case, that Joe Fox's data was showing a shift in the C to N ratio, where there's a whole lot more carbon to nitrogen in these samples taken from the northern Gulf of Mexico, and that increases, by as much as 5-fold by the time you get out into there. Now that would suggest a net transport of nitrogen out of the Gulf of Mexico and an absorption of nitrogen by the planktonic community in the Sargasso Sea, and that would be consistent with what we know about an oligotrophic and nutrient-poor environment, where perhaps the primary producers are making use of whatever source of nitrogen that they could. So that's his data, and this is from an unpublished manuscript which he was kind enough to send me to show here. So these are his conclusions that this is the medium resolution infrared spectrometer sensor, has bands that give a good estimate for sargassum from these satellite observations. These satellite data suggest that the Gulf of Mexico is the major source of sargassum, at least in the period of 2002 to 2007. Rather than recirculation and growth in the Atlantic. And that's a fairly radical claim, I think, that he's making here, at least based on the life history studies that we've seen earlier. The time series data show that the Gulf 2005 was a very large sargassum year. We also know that the Gulf 2005 was one of the warmest years on record for surface water temperatures, and that's was also, of course, the Katrina-Rita year. And those factors are all related to that higher temperature and the higher heat potential of the Gulf of Mexico. This year, for the first time, we see a lot of sargassum in the Atlantic, northeast of the Bahamas in March and April. Is there a shift in the production and the export of sargassum out of the system, and is that related to changes in sea surface temperature? I think these are questions that are kind of intriguing. For the much more regional and local concerns that have been raised in this meeting here, I think the prospect is for utilization of these data, which are collected with a fairly high time constants, as a means of predicting how large the sargassum crop or the sargassum infestation, or however we want to think about it, is going to be in the Corpus Christi beaches on a seasonal basis. So that if we could use the satellite data to predict what the landings are, perhaps our beach management and our sargassum management procedures could be more rationalized. So that's what I have from Dr. Jim Gower, and I'll try to answer any questions that you might have on that. Thank you. Yes, Tom.
Could you use the same satellite data to predict when these masses might be washing ashore in the highest amount?
Well, I think that the data would give you a good handle on the total crop. The washing ashore would depend on more on sort of oceanographic processes. But I think seems like it would be possible.
I mean, if you had a time series, it looks like you could see what
right.
moving ashore.
Exactly. And one of the things that when I spoke to him on the phone over the weekend, one of the things he requested was look at Tony Amos's data to see if there were, we could go back over time and make hindcasts based on the satellite data as to when the largest landings of sargassum might have occurred in the past to test exactly that kind of model. So I think that really is intriguing, and it's. I also find this intriguing because it's giving us this sort of global picture of what's really a very, very large ecosystem, and clearly an important source of carbon and possibly nutrients for the entire ocean.
Maybe it wouldn't behoove you to clean the beach this week, but wait till next week.
Wait till next week.
All this is coming ashore.
Exactly. Other questions?